3.9. It's called Law of Sines. We just got 2 more lessons before your test. So we're going to shake things up a little bit. So far, let's review what we have done thus far. We know we have solved triangles with Pythagorean theorem. A squared plus b squared equals c squared. We know we've also solved triangles 30, 60, 90 or 45, 45, 90. Those are the special right triangles. And then more recently, we solved triangles using sine, cosine, and tangent, our trigonometric ratios, as well as their inverses. What is common amongst all 3 of these methods so far is that they only work if I have right triangles. I have to have a right angle for all of these. So used for right triangles. But what happens when we don't have right triangles? Can we still solve those triangles? The answer is yes. And we're going to start doing that today and tomorrow. So law of sines is our very first method for solving non-right triangles. Okay, so basically what the law of sines is, it's a fancy proportion. We know proportions, right? It's a fraction equals to another fraction. In the law of sines, we have 3 sides, 3 angles in every triangle. We are going to line up a side angle pair that is opposite one another. So for example, capital letters refer to angles. So this is angle A over here. And lowercase letters refer to sides. So that's little a. So they are across from each other. So angle B is across from side B. Angle C is across from side C. Capital letters, angles, lowercase letters, sides. Here's my proportion that I'm going to set up for every single one of these problems. Oh, there we go. I'm going to have an extended proportion. I can say sine of angle A over the side A is equal to sine of angle B over side B. Okay. And those also go hand in hand with sine of angle C. Sine of angle C over side C. So you're not going to have a big extended proportion like this. You're going to just do like a fraction equals another fraction. But you can mix and match, whether you do A and C or B and C or A and B, right? Mix and match. That's it. That's our proportion. It's not too bad. The hardest part is going to be solving these. So let's take a look at the first example here. It says find the unknown value and round to the nearest tenth. So what I'm looking for is this side length E. Now, when I start these problems, I start by lining up the opposite pieces. An angle goes with a side. Again, here, an angle goes with a side. That's all I need to set up a proportion is 4 values, and one of them can be a variable. So the first thing I'm going to put in my proportion is that sine of 28.7 over 8.3. That's the first thing I have. And it equals, on the other side here, sine 59 over E. Do we remember how we solve proportions? Dahlia? We're going to cross multiply. So to cross multiply this, on the left side here, I'm going to put E times sine 28.7. And on the right side here, 8.3 times sine 59. Now our goal is to solve for E, so I need to get E by itself before I do anything else. I'm going to get E by itself. You see how it's E times sine 28.7? That means I need to divide by sine 28.7. If I am not solving for an angle, I don't want to see any inverses in your work. I'm solving for a side length. I don't need an inverse. So this is E equals 8.3 sine 59 over sine 28.7. Now we're going to put this in your calculator. Here are some things you need to know when you put this in your calculator. Anytime you type a trig function, you know you get a parenthesis, right? So you should always be closing that parenthesis. Then, anytime we do a fraction, we should also be putting the numerator in parentheses. We might have to put the denominator in parentheses too, but not in these problems necessarily. So that one goes in parentheses. You can technically put this denominator in parentheses like so, but there's only really one thing in there, so it shouldn't freak out. So that's a lot of parentheses. The important thing is, if you're getting domain errors or whatever it is, it's because your parentheses are probably wrong. Okay, so let's take a look at putting this into my calculator. Let me go over here. And I have, what did I say? 8.3, so parenthesis, 8.3, sine, look how that opens up a parenthesis, so sine 59. I got to close that one, and then close my numerator, and then divide by sine 28.7, and close that. So we should be getting 14.8. Any questions on that? Okay. So let's do that. E equals 14.8. Amazing. All right, let's do another one. In number 2, I have all these values, and I'm solving for angle R. So I'm going to connect up what I have. I have 9 goes with angle R. That's the one I'm trying to find. And 47 goes with 13. So my proportion will look like sine 47 over 13 equals, and this time the variable is going to go in the angle spot. This is sine R over 9. We're going to cross multiply. So this is 13 times sine R equals 9 times sine 47. And then now we're going to think about what we have to do. I'm trying to get R by itself. So the first thing I can do is divide this 13 out of the way. So I'm left with sine R equals 9 times sine 47 over 13. And I cannot divide by sine. The way that I get rid of that sign, because that sign is sticking with that R, is I have to do inverse sine of both sides. And that makes sense because anytime I am solving for an angle measure, which R is an angle, I have to use an inverse somewhere. So now I'm left with R equals sine inverse of 9 times sine 47 over 13. Look at where these parentheses are going to go. When you start typing in sine inverse, you're going to get this first one. Then you need to put parentheses around your numerator. Then when you type in this sign, you're going to get another set of parentheses, which you close after you type 47. You got to close your numerator, divide by 13, and then close the whole thing. There's a lot of parentheses that are going on in here. Let's type them out. So I want sine inverse. Numerator is 9 sine 47. Close the sign, close the numerator. Divide that whole thing by 13. Close the inverse sign. Hit enter. I got 30.4. Is anybody not getting these numbers? Check your mode is in degrees. Everybody good? Okay. All right, let's move on. What did I say? R equals 30.4 degrees. Look at the next page. We're essentially doing the same thing here, but now instead of just finding one part, we need to find all of the missing pieces, which isn't going to be too bad. In number 3, we got to figure out what do we have first. So I see a pair of things already. 34 and 27 go together. I want to make another pair of angle side. So I'm going to put together 9.1 and this angle F. So let's say sine of f over 9.1 equals sine of 34 over 27, and cross multiply. 27 sine f equals 9.1 sine 34. I know I'm solving for an angle, so I know I'm going to need to do an inverse in a second here. We're going to divide by 27 first. And then I'm going to do the inverse sine of the entire thing. So f equals sine inverse 9.1 sine 34 over 27. You should not be simplifying anything until you put the entire thing in your calculator. We don't want to do any rounding in between. So let's do inverse sine, second sine of, what did I just say? 9.1 sine, oh, I didn't put this in parentheses, sorry. 9.1 sine 34 divided by 27, close my parentheses. Oh, I did not, oh, sorry, not 24, 27. Oh, I did put 27. Did I type something in wrong? Oh, I think I put 9.7. What did I put over here? 9.7, 9.1. There we go. That's better. 10.9. Questions on that? 10.9. Everybody got 10.9? Okay. So that's this part right here. Now, we got to fill in the rest of this. We are going to be able to get some freebies, hopefully. One of the most common freebies that we get is if I already have two angles in a triangle, can I not just subtract them to figure out what the third angle is? So that's what we're going to do for angle D. To find angle D, I'm going to do 180 minus the angle 34 minus the angle 10.9 that I just found. And that gets me that this angle is 135.1 degrees. So this is a little freebie. And then I got to set up one last thing to find the side D. D has to go with this angle, 135.1. So I'll set up sine 135.1 over D. I'm going to use the one that already was given to me, so sine 34 over 27. And then once again, we're going to cross multiply to solve. D sine 34 equals 27 sine 135.1. We're not finding an angle, so we don't have to use any inverses. I'm just going to divide this whole thing by sine 34. D equals 27 sine 135.1 all over sine 34. 27 divided by sine 135.1. Oops. I need parentheses. 27 sine 135.1 divided by sine 34. $34.1 it looks like to me. And there we go. Any questions on this? We gotta do one more, then I'll leave you alone. All right. Number 4, again, do I have a freebie right away? We should be looking for this. Do I have two of the three angles? Yes. So I should find that first. Here's my freebie. I do 180 minus 77. Oops, 77. Minus 43, which is 60. So this angle over here is 60. And now I can just set up a bunch of law of sines proportions. So let's do the first one. Sine 43 over 0.8 goes with, let's do F first. So F is sine 60 over F. The other proportion, which I'm going to set up at the same time for the sake of time, is sine 43 over 0.8. This time I'm going to pair it with the r's. Sine 77 over r. Again, cross multiply. You don't have to do any inverses because we're not finding any angles. I believe your answer should be that f is 1 and r is 1.1. Any questions on this? We're okay with that? Homework's in your packets. Go ahead and get to it.